So let's do a multi-threaded problem today. Fizzbuzz multi-threaded. So, you know, normal Fizzbuzz is to print out a sequence of numbers from 1 to n, except that certain numbers we might print Fizz if the number is a multiple of 3, but not a multiple of 5. And buzz if vice versa, if number is a multiple of 5 but not a multiple of 3, and if a number is both a multiple of 3 and a multiple of 5, we print fizzbuzz. If a number is, i.e., if a number, since 3 and 5 are relatively prime, if number is a multiple of both 3 and 5, a number is a multiple of 15. So if number is a multiple of 15, we print fizzbuzz. So in this specific question, they divide the different printing utilities as into different threads. So this corresponds to thread A, which can only print the fizz since it's past specific functor or a specific callback. Print fizz. This function corresponds to thread B, which can only print buzz. This function, and so on and so forth. So since we have different threads, how are we going to, I guess, synchronize them? So we have thread A, it can only print fizz. Thread B can only print buzz. Thread C, fizzbuzz. And thread D prints the numbers. And we synchronize. So basically, the execution would look something like we would start with 1, which is just a regular number. 2, and then we would get to 3, that's a fizz. You would trigger fizz, it's not a multiple of 5, it's just 3. So fizz. 4, we're back. We must return to thread D. 5, buzz. So on, so on, so on. So how do we manage? Since each thread can only do one thing, how do we manage the state between the threads? And we must, it might be a good idea to take a look at something called a semaphore. So here the problem is getting from this thread to this thread to from handing off the control flow the proper sequence between the various threads. We must, for example, get from here to here, here to here, so on and so forth. And we can actually accomplish that with something called a signal or a semaphore. A semaphore. Let's liken it to, I guess, a jar of marbles. 2 marbles, let's say, starts an initial state with 2 marbles. Thread 1 comes along, calls wait on the semaphore. It sees that there is availability, there is a marble in the jar, so it immediately takes the marble, then continues executing the perhaps restricted code. And then we have another thread, T2, that also calls wait on the semaphore. It sees that there's a marble in the cup, gets the marble, continues on with execution. But now we have a third thread. It sees that there are no marbles in the thread, So it's blocked from executing until a marble gets put in back in the jar with some other thread calling post, and only then will it be able to continue execution. So something called a binary semaphore can be used to notify the threads to hand off control between the different threads. So this thread can signal the fizz semaphore. This thread can signal the numbers semaphore, and so on and so forth. May be easier to see the code, so let's just hop on there. Let's actually get into the code. Here, let's use the semaphore class, or the semaphore API is the C API, since I could not find a way to get this to work here. So let's just use a more primitive version, which the C++ version, i.e. the STL version, is probably based on this underlying pthread implementation. So let's include semaphore.h, and now we can define a semaphore for this one. API is semt. Let's just call it S3. It's multiple 3. Semt S5. What's this thread will be listening on this. Semt S15. Fizzbuzz. This thread C will be listening on this. Finally, semt for the last one, the generic one will be, let's just say S. And for the POSIX semaphores, these are just memory locations. We actually must call an extra function to initialize these semaphores. So that would be sem_init. First takes address to the memory location where the semaphore needs to be placed. This is an argument we can ignore unless you're dealing with multiple processes. Here, each thread is part of one process here, so we can leave it as 0. It doesn't matter to us. And initially, the third argument is how many marbles do we want to have in the jar initially. And since we don't want this thread Fizz to be printing things before this thread D numbers, we want this thread to start things off with 1, 2. We don't want this thread to be printing Fizz willy-nilly, as out of order. So let's just initially give it 0 marbles. Again, similarly, we repeat this for the other semaphores, S3, S5, and S15. But for the base semaphore S, we actually give it 1 marble, since we want it to just start things off. We don't want it to wait for anything. So Fizz, as I said, it's dumb. It's only given the ability to do one thing, and that is to print Fizz. So the idea actually is not to have some shared variable keeping track of what number threads should be on, but each thread should, I believe it might be easier to have each thread have a local counter and only deal with the variables it can deal with. Since this can only print Fizz, it can only deal with those multiples of 3 that are not multiples of 5. but it will be easier for each thread to have a local counter. So let's do that. Well, it starts with I is 1 is less than n plus plus. And if it's a variable we want to deal or we can deal with, so if it's a multiple of 3, and this logic tests if it's a multiple of 3 and not a multiple of 5, so this would evaluate to 0, and overall evaluate to true. I, 5. It's not really important. So first, we don't want it to print it immediately because, you know, the other threads have their own counters. So we would need to wait on this semaphore created just for this thread. So sem wait, and this just takes the address. Only afterwards can we actually print Fizz. And, you know, after we do this, we would need to somehow hand off the torch to a different thread. Also, that thread would need to hand off the torch, so on and so forth. So notify the appropriate thread, and we can do that later. Similarly, for Buzz, it's almost the same logic, just waiting on a different semaphore. Printing Buzz. And similarly for this one, here's Buzz. And we just check if it's a multiple of 15. And if so, we do the needful wait on S15 and print is Buzz. And afterwards, we can't forget to notify the appropriate thread as to pass on the torch to, you know, whatever thread that handles, like for 16, for example, which is this one. So here we do the same thing and check if it's not a multiple of 3 or 5. We wait on the base semaphore and we actually print a number. And notify how we would want to implement something that actually calls sem post. Notify. What arguments should it take? Well, so the threads are called based on this number. So after Fizz, after this, we go on. Let's say we are on 3 in this function. We are on 4, and then given we're on 4, we know exactly which one to call, which is this one. So we just need the number next. And this, like, for example, if next were 16, it would wake up the appropriate, or it would post on the appropriate semaphore here. So if number is a multiple of 15, next is a multiple of 15, we would just do just that. Else if next is multiple 3, else if this is a multiple of 5, else we just post the S. And we actually would need to call, since we are on I, we notify I plus 1. That's the same for each. And you see, so let's, for example, if we were in this thread, we're on if I is equal to 4 here, and we would notify I plus 1 equals 5. 5, we would post on S5, and if this buzz were blocked waiting on this S5 here, it would be released from its sleep and be able to print buzz, so the order is maintained. Print 4 and then buzz instead of printing just buzz randomly. It just isn't any fun. So I have actually done this problem a few hours ago, so it should work. Hopefully it does. There's still, I guess, sort of nervousness about it. So let's run code. It looks like it does. Let's actually submit. It looks like it's a very slow solution, but this, I believe, is notoriously inaccurate. So if you submit again, you may receive something completely different. And perhaps if you submit 100 times, you can somehow brag that you got a 99.99% submission. So anyway, I hope this helped you both relax and both gain some, I guess, knowledge about specific problem. It's the concept of a semaphore, the specific, I guess, C API, even though it's not that much used anymore. And I wish you a wonderful night. Have a good night.